La gente estaba en su meeting.
En la primera clase 17 y 19. No muchos.
Estuvo bueno.
Bueno, vamos a ver. Screen. Ahora sí. Okay, here is the problems we are going to solve, correct? So the first problem is for x positive, the horizontal line y equals 2 is an asymptote for the graph of the function f. Which of the following statements must be true? So we have to select the necessarily true. Possibly one of some of them are true in, well, different circumstances, correct? But, yeah, we have to select the one that pretty much must be true, correct? Entonces, let's see the first one. So, is, déjame copiarlos, f of
¿No?
equals 0, b, f of x different than 2 for all x positive. Yeah, see f of 2 undefined. This is the limit, right? And e limit. Okay, let's go back to the board. These are the answers, correct? So these are the answers here. Now, let's just sketch the possibility. Remember, this is no calculator allowed. So they tell you that y equals 2 is an asymptote. So, okay, y equals 2 is going to be a horizontal line like this, correct? Asymptotic behavior means that of the function is going to do this, correct? Or this, or is going to do this or this. I don't know what happened here. It's a mystery, correct? But here and here, the function has to be approaching 2 as x increases. So here, f of x approach 2 as the x increases, correct? Here the same. F of x equals approach 2 when the x decreases, right? But there is a problem here. The x is positive, so this portion cannot exist. So which one of the 4 of the 5 could be necessarily true?
D.
D.
Yeah.
Fíjate bien. Its limit when you approach 2 is infinity. What is this one? Let me just put it right here. Limit when the x approach 2 of f of x is infinity.
Oh, that's a vertical asymptote.
That's a vertical asymptote, correct.
Ah,
So
sí, ¿verdad?
you are doing this or you are doing this, correct? So este no necesariamente es cierto.
Es E.
Es esta, correcto. Because x is positive, this is positive x's, correct? And this is the definition of an asymptote, horizontal asymptote. The limit of f of x equals 2, correct? So my correct answer is E. If you see, in these problems, we don't have a... Déjame imprimirlos mejor. Déjame imprimir esto. Print, porque así me voy más rápido. Déjeme poner esto. Mira, más chancito. Oops.
So I'm gonna go.
Ok, ¿todos de regreso?
Sí, tú,
No sé por qué se
usted era el
perdió.
único.
Yo no sé por qué se perdió esto, pero bueno. Cosas del internet. Dice, your internet connection is unstable. No sé qué pase, pero bueno. It's the first time happening this one. Déjenme abrir un archivo, ¿no? Ok. Ok. Déjenme abrir un archivo nada más. Ok. Practice test. Oh, man. Ok. Users, Miguel L. M.
Leo.
Ramirez.
Yeah.
Garcia's gonna start doing the same thing Ramirez is.
Oh, I know.
Ugh.
Record.
Huh?
Tell them to record.
Oh, yeah.
Limits and continue. Ok.
¿El internet se fue o qué, Ramírez?
No, estoy tratando de imprimir algo. Espérenme tantito. File print. Para irme más rápido. Social legit. So, páginas 1 through 5. Ok. Más denme un chance. Déjenme ver quién me escribió.
Mire, ya picó.
Ok. Listo. Sorry about this gap. But now I'm here back, okay? So any question about this problem? So fine? Piece of cake? Okay. Vamos a borrar. Now, here I have the problems, correct? So let me just again share screen. Yeah. Aquí está. So aquí está. This is the one. Y de este sí se tienen que acordar, ¿ok? Dice, what is the limit of this quotient of polynomials of this rational function when the x becomes very, 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 very big? So I have this limit.
Y no puedes usar calculadora.
No.
¿Qué no sé?
A ver. It's very simple. Les voy a enseñar el truco. Right?
No, pero el hospital.
No. Más rápido que eso. ¿Sí? A ver, déjenme regresar aquí. Stop share this one. Now, this is our limit, correct? Okay. What we have to do is, como todo, right? This is a class. This is the big boy in the class. So the class is going to do what the big boy says, correct? So when the x is very big, this is the significant term. Si esto es 100 millions, 100 millions cubed is more than 100 millions squared, correct? And more than 100 millions and more than 1. So because this is a multiple choice, we don't have to break our neck trying to do the detailed algebra. This is the point. This is the approximately the limit at infinity of what the two big boys are going to do. So is x cubed over 4x cubed. So check that I'm putting here an approximately, correct? The symbol is approximately the limit at infinity of the two big boys. Now, what algebra you can do here, Leonel? What you can do with the x cubes?
No, cancel out.
Correct. So this is the same. If you cancel out the x cubes, this is the limit
God.
at infinity of 1/4. And this is a horizontal line, correct? If you graph the 1/4 is this one. This is y equals 1/4. What is the limit at infinity of 1/4? 1/4, correct? The limit at infinity of a constant is the constant, so this is my answer.
So the others don't matter?
No, ningún importa, porque as much as this increases, the cube goes faster than the square and much more faster than the x. Pon aquí, estos son 100 millones. 100 millones cube is more than 100 millones square, correct? So this is the one that is going to tell you the behavior of the top expression. This is the term that is going to tell you the behavior of the bottom expression. So when this is very big, esto significa a very big number, remember. What number, I don't know, it's just very big. So these two are the ones that are going to determine the behavior. So just put them by themselves. You cancel the x's, and then you get a constant. Well, the limit at infinity of the constant is the constant because this is a horizontal line. The horizontal is always horizontal. Okie dokie? Yep. You want another problem like this?
Yes.
Vamos a ver. Déjenme ver supuestamente. Es el limit at infinity of 2x squared minus x minus 1 over x squared plus 2. Okay. Now again, you check. Okay, I'm going to work with very big numbers. This infinity is the meaning of that. Okay. Who are the big boys in the class?
2x
X squared and this one. So I'm going to cover the other terms. You see? What is this expression equals to?
2.
That's it. So what is going to be the limit of this expression?
2.
That's it. Correct.
Pero, okay, so make it 2x cubed. Ahora, ¿cómo lo haces?
Here?
Yeah.
Bueno,
Make
vamos a
1
ver.
cubed and 1 squared.
Voy a ponerlo aquí. This is 2, right? Because these are the significant terms. Let me just put it here. And ponerlo aquí. This is approximately the limit at infinity of 2x squared over x squared. So this is the limit, right? At infinity of 2. And this is a 2, correct? Everybody catch this procedure?
Mhm.
Now, what happened as Sergio is asking? So suppose I have the limit at infinity, right, of 2x cubed minus x plus 1 over x squared plus 2. Suppose that one. Okay. The reasoning is the same. Who's the big boy at the top?
2x cubed.
Entonces pongo limit at infinity of 2x cubed. Who's the big boy at the bottom?
X squared.
X squared. Now, simplify the expression. Limit at infinity of
2x.
2x. Okay, now, what kind of function is this? Well, if you remember, 2x is a function like this, correct? What is the behavior of this function when the x increases?
It goes to infinity.
Correct, it's infinity. You see that?
Oh.
So, because this is 2x, what happens when the x increases? This line goes forever, correct? So, to infinity. So,
That's what it
the
reacts, right?
limit when the x increases of this function is infinity, correct? Remember that this is the behavior. You increase the x, you increase the fx, okay? So that's the idea, okay? Now, what happens if the cube is at the bottom? Vamos a suponer que alguien me pregunta, what if the cube is at the bottom? Okay, 2x squared plus 2, or 2x squared plus x minus x plus 2 over x cubed plus 2. Suppose that one. Okay, reasoning is the same. This is pretty much modeled by the behavior of the big ones, x cubed. Now, x squared over x cubed, what expression is this?
2x.
2 over x.
Correct. X at infinity, 2 over x. Now, what is the behavior of this function? This is the reciprocal function, so the reciprocal function behaves like this one, correct? That's the reciprocal function, right? So what is the behavior of this function when the x increases? This line approach to what?
Yes, se fue.
Approach the axis, correct? At the end, this is going to be 0. Okay? You see that? So 2 over x, when the x is very big, 2 divided by a very big number is practically 0. What do you divide this by the greatest number you can imagine? It's 0. So that's the behavior. So remember these limits before? Bueno, déjenme ver y les doy otro.
Okay.
Voy a buscar el libro. Let me just...
My God.
Ramirez,
¿Qué pasó?
you're cutting out.
¿Sí? ¿Se está cortando?
Sí.
Okay. Well, it's the internet. It seems unstable.
Go restart your router.
It's possible.
Ponga otro.
Apágalo y préndelo. Eso siempre jala.
Con otro internet.
Compra otro internet.
Llámale a AT&T. ¿Por qué no jala? Okay, that problem. You see that problem?
Sí.
Así, as we say in Mexico, sin ponerle las manos, just by feeling, what is the limit?
Four. -4.
-1. Areli,
Hmm?
what is the limit? Así,
Negative.
just al feeling.
-4.
-4, that's correct. Because between this, when this is very big, 4 times 1,000 is more than 1, for instance. Suppose the x is 1,000. This is 4,000, this is 1. This is 1,000, this is 1. So you can pretty much discard these numbers and then you have 4x over x. How much is that? 4. So my limit is 4. Okay? There are more difficult, yes. Les voy a poner otro, mira. Limit at
Is
infinity.
+4 or -4?
-4. Square root of x squared plus x over -2x. A ver ese, muchachos. Acuérdense, separen la clase. Who's the big guy here?
It's 1 over -2.
A ver, fíjate bien. Bueno, sí, 1 over -2. So, let me just do the thing. Limit at infinity, you have a square root of x squared, correct? Minus 2x.
And then you
Okay,
cancel the
this
square root.
cancels out. So this is x over x. So this is the limit at infinity of -1/2. And the limit of a constant is
A constant.
the constant. Ahí está. Any problem with these limits? This is easy. And remember, you don't have to show any work. Yes, like in this one, this is okay. This is -4 divided by 1, -4. That's my limit. Because this is multiple choice, there is no work to show. So I'm not wasting my time how to calculate this step by step, correct? So, everything fine with the limits at infinity?
Yes.
Okay.
Ramirez.
Let's go to the next problem now.
Ramirez. They sent me, ¿me escucha?
Sí, claro.
They sent me a survey about the test. Y decía, like, how would you feel about taking a calculus test without free response? Eso es lo que decía para todos los tests, que todos eran free response.
Without free response?
No, with just free response.
With just free response?
Todos los tests.
No sé. ¿Cómo pueden hacer un free response?
Ay, déjame checo.
How can they create a free response test online in
They were
45
saying
minutes?
You can
So these
submit
are the conditions for the test, mira. 45 minutes only. At home with a computer. So what you can do in 45 minutes? Multiple choice or free response? How do you write all the work for them?
Sí dijeron eso, que iba a ser free response. Y como quiera, ¿cómo vas a hacer cálculos en una computadora y hacer free response?
No, they were saying that you can submit your notes.
Tomar una foto y mandárselas, take a picture and send it. So let me check this one because my understanding is that it is going to be multiple choice for calculus. For the math, so any of these problems requires a lot of writing, correct? What is going to be? Ahora, vamos a ser realistas. Let's be realistic. So this is going to be a short test anyway. So we're studying because this is positive for you in college. You are learning. I cannot guarantee you that college are going to take the score. Si antes el examen completo no lo tomaban, ahora no sé. College Board dice that in past times, in past situations, college did it. Pero en los últimos tiempos no tomaban el examen las escuelas de ingeniería o ciencias. UT, UH, Texas A&M, Stanford, acuérdense de González, right? Se fue a Stanford y no le tomaron APCalculus. So, Vamos a aprender. Tenemos este tiempo, vamos a aprender, ¿ok? Bueno, vamos a ver este problema. Let's deal with this problem, ¿ok? So we have, this is 2003 problem 20, no calculator. Now you have a piecewise function. F of x equals x plus 2, for x less equal than 3, for x minus 7, for x more than 3. Let f be a function given below. Which one of the following statements are true about f? So again, we have to select the one that is necessarily true for f. Okay. Again, we are not going to show work, so we can do some tricks. For instance, what is the value of this function in 3? Okay, you put a 3, 3 plus 2 is 5. What is the value of this function in 3? 4 times 3, 12, minus 7, 5. So both are 5. So the two lines join at 5, correct? You visualize that? Okay, technically you cannot put a 3 here because this is for x greater than 3. But mentally you can do it and you see that the two lines join at 5. So number one, yes, limit exists. So the situation, let me just put it right here. Let me just write this here. Yep, let me just put it right here. Stop sharing, right? We have this function, correct? So the situation is very simple. In 5, they join. So from the left, from the right, you go to the same point. So the limit of f of x when the x approach 3 is 5. So exists. So the limit exists. So number one is true. From the left, from the right, you go to the same value. So that's a 5. F is continuous at x equals 3. This is well. If the two lines go to the same point, this is continuous, right? Continuous. So number 2 is also true. What about the last one? A ver, Brandon, usted que es el campeón de los robotics.
No sé qué significa.
Este. F is differentiable. Déjeme poner aquí otra vez el papel here. Aquí dice F is differentiable at x equals 3. What does mean that? The derivative exists, correct? What is the derivative? The slope of the tangent line, correct?
No existe.
Why?
Because at a point, there is no slope.
Más bien, you have a peak, and you have many tangents in a peak. Why? Because this slope is 1 and this slope is 4. So really, the thing is something like this, correct? Slope 1, slope 4. So you have here a peak. So how many tangents you have? You have many. So it's undefined. So M is undefined. So the number 3 is not happening for this one. So is continuous? Yes. The limit exists? Yes. Is differentiable? No, because you have a peak. Correct? So number 3 is no. Okay. Now remember, even if we had a calculator, these problems do not require a calculator. Vamos a ver el siguiente. Let's do the next one. Let me just share screen. Dice aquí, for which of the following the limit of the function of 4 exists? You remember the picture I have in my room of the two hands pointing to each other? So that's the limit. From both sides, from both sides, you must approach the same point. Remember the two hands, correct? Now I'm going to do the same here in the picture. If you put your fingers right here, this finger is going to land here in this little hole. What about this finger?
Bien.
Same, correct? So the limit in 4 for number 1 exists. What about for number 2?
También.
What about for number 4?
No.
No. The two fingers are separated. One is pointing up and the other one is pointing down. They are separated, right? So this was never painted by Michelangelo, right? Because in this situation, nothing happened. Michelangelo painted this one. So something was going to happen, right? So this, the limit does not exist. So if you return to your problem, so the answer is
D.
A, B, C, D, E. Which one?
D.
Correct. So you see, it's not very difficult. So there are multiple choices that are simple. Now my situation is, I have no idea what multiple choice they are going to put, okay? No lo sé. I don't know. These are the regular when you are testing with somebody. Bueno. Ahora sí, let me see if you understood what happened in the previous problem. Okay? Otro limit at infinity. Another limit at infinity. Ready? A ver. Work it out and tell me the answer.
Okay.
One.
This is in el 2008.
Ocupo un papel, Ramírez.
You see the paper?
No, yo ocupo uno.
Ah, okay.
Let's see.
No, es B. Es B.
No problem with that. Okay. Who's the big guy at the top?
Negative 2x squared.
Negative 2x squared. That's correct. Who's the big guy at the bottom?
X squared.
X squared. 2x squared over x squared? Negative what?
Negative 2.
Negative 2. That's correct. So you have a parabola at the top. You have a parabola right here. Yeah. You have a parabola right here. The x squared cancels. You have 2 over, obviously, negative 2 over 1. So negative 2. Okay. Now I'm going to switch the thing for this limit. This is not at infinity. This you have to do the algebra. Okay. Let me just put this down. Yeah. Limit when the x approach 0, 5x to the 4 minus 8x squared and plus 8x squared over 3x to the 4th minus 16x squared. Okay. Now I'm going to go to the board. Oh, here is the problem at the board, correct? Okay. This is a 0. This number is defined. Infinity is not a number, it's just that the value increases. But this is a 0. So remember, what is our first step? Our first step is we have to evaluate x to the 4, x times 0 to the 4 plus 8, 0 squared over 3 times 0 to the 4 minus 16x squared. Now, how much is this value? Well, at the top I have a 0, and at the bottom I have a 0. So the limit
Exists.
the function has no value, so the function is undefined. But remember that a 0 over 0 means that something can be canceled with something here at the bottom. Something at the top can be canceled with something here. So I have to do my algebra. This is, okay, green. Let me just green. So 5x to the 4 plus 8x squared over 3x to the 4 minus 16x squared. Now, we have to factor and cancel. So I'm going to factor here completely. And I'm going to factor here completely. Correct? Now remember, my assumption is the x is not 0. Because if this is 0, I cannot cancel the zeros. Okay, Brandon, what you cancel out on that expression?
The x squared.
Correct. I cancel the x squared. So for this function, I found a twin function. Remember the twin functions? Functions that look the same, but they are not exactly equal, right? So once you find the function, you take your limit. Limit, when x approach 0, of 5x to the 4 minus 8x squared over 3x to the 4 minus 16x squared is the limit in 0 of 5x squared plus 8 over 3x squared minus 16. And then you evaluate. So 5, 0 squared plus 8 over 3 times 0 squared minus 16. My answer is
Negative.
negative 1/2. Correct? Okay. Imagine that you receive this problem in the test. You see how much we have to work? ¿Dónde vamos a poner todo esto en un examen? Online. O sea, ¿puedo tomar una foto y subir la foto? I don't know. So I don't think there is going to be open-ended questions. They are going to be multiple choice. You see? Just this problem is a little one. We're not going to show this work. Okay? Okie dokie. Now, this is to refresh you about the method. Okay? You should be faster than this in the multiple choice. Correct? So you have to see here in this portion, right, that you can cancel something, x to the 4, you can cancel something. So the real way I want you to do is this one. This is okay. Plus 4 is to 16 x squared, right? So this is going to be, if you put, this is okay, this is 0 to the 4, 0 squared, so this is 0 over 0, correct? Now what you're going to do simply is, okay, this is the limit, and then you see, okay, x squared here and x squared here. So x squared, 5x squared plus 8 over x squared, 3x squared plus 16. And this one was minus, right?
Yeah, it was
This is
mine.
minus. This is minus, this is minus. So you see, I'm doing the algebra in the same expression. So I cancel, right? And then I put the value, 5 times 0 squared plus 8 over 3 times 0 squared minus 16, and then you get the same answer, correct? Negative 1/2. You see, I shorten in the procedure. So I'm going to do the factoring inside the limit, and then I'm going to evaluate once I cancel something, correct? It's faster. You're in a multiple choice. You have just to get the answer. And this is no calculator, okay? Somebody says, why we don't use L'Hopital? L'Hopital is the derivative of this over the derivative of it. You have to do 2 derivatives to get this answer. Let me just show you. So, L'Hopital says the limit in A of f of x over g of x is the limit of g prime of, no, f prime of x over g prime of x when the x approach a. So in this case, let me just put it right here, sería a limit, the derivative, 20x cubed minus plus 24x over 3 por 4, 12, x cubed minus 32x. If you put a 0 here, you again get 0 over 0, you see? Tienen que hacer otra derivada. You have to do a second derivative. Okay, vamos a hacer second derivative, right? So this is the limit because this continues f of the second derivative,
Ramirez,
y second derivative. Yes?
el 24x should be 16x, no?
Espérame tantito. ¿En dónde?
When the first derivative, the 24x.
3 por, a ver, este es, no, 5 por 4, 20, 3 por 8, 24, 2 por 6, 32, 3 por 4, 12. Este es 4.
Pero 8, it's 8x squared, not 8x cubed.
Ah, sí, es x. ¿Es 8x square?
Yeah.
Ah, sí, cierto, es x square. 2 por 8, 16 entonces, cierto. 16x, ahora sí. Ok, segunda derivada, second derivative. Derivative of this is 60x plus 16 over 32, 36x minus 32. Now, when you evaluate, you get 16 over negative 32, and that's the half we had before, right? So, which one is longer, the previous one or this one? Well, in this case, this is longer than the other one. So, this is an efficient method, right? We're going to use this one, for instance, here. Let me just erase this problem. And suppose this one is okay. Limit when the x approach 0 of sine x, right, over x. Well, if you evaluate this limit, this is sine of 0 over 0. This is 0 over 0, okay? It's undefined. Now, there is no way to cancel these x's, correct? We cannot factor an x and cancel out. So it's in this situation when L'Hopital works, because this is the limit. What is the derivative of the sine? Cosine. What is the derivative of the x? 1. Now you put the 0. Cosine of 0 is 1. That's it. So this is good when you have functions that the sine, the cosine, the logs, those functions that you cannot factor with an x. Correct? So this works fine. So L'Hopital works fine, but...
Pero también nada más se puede hacer sine u over u.
Yeah, también. Okay. Okidoki. Questions, muchachones? Bueno, vamos a hacer un par más. Let's do a couple more. Yeah. Let's go back to the screen. Okay. Same kind of problems as before. A ver, if you solve it. Let f be the function defined above. So this piecewise function, right? What of the following statements about f is true? F has limit at x equals 2. F is continuous. F is differentiable. Same questions.
Ooh.
Can you answer the first two easily?
Yeah. 2x squared. 2 squared is 4 minus 1 is 0. One and two aren't true.
Okay, vamos a ver. Let's go back to the algebra again. See, let me just put this one right here. Let's just write it down. F of x equals x squared minus 4 over x minus 2.
Oh wait, no, it is true. One is true, two is not.
Okay, let's analyze this one. Here is the board, correct? So we have here the function. Okay, here is the trick. This function, can you reduce that function? Is x squared minus 4 over x minus 2 is equal to something?
X plus 2.
X over 1.
X plus 2, that's correct. Because this is x minus 2 times x plus 2 over x minus 2. So you simplify, you get x plus 2, correct? Now, let's see what happened here. What happens if you take the limit of this expression? What you get? So if you put, for instance, in 2. So suppose you get limit when the x approach 2 of f of x. So we have to use this expression. So it's the same as the limit when x approach 2 of x squared minus 4 over x minus 2. And according with this, we found this is the limit in x plus 2. Now, what is that limit?
4.
Well, you put a 2 here, that's a 4. So this is the point. This is 1 and this is 4. So my graph goes here at 4. And this point in x equals 2, this is x equals 2, correct? This is for x equals 2. This is right here. So this is the situation we have. Now, according with this situation, right? Let me just go back to the paper. Which one is true?
1.
1. What about 2? No, it's broken. And what about 3?
No, it's a point.
There is no point, so you cannot plug a tangent, correct? So the answer is only 1. So my answer is this one, you see? Now, I'm going back to the reasoning. Is my reasoning clear for you? Yeah? This is something you can simplify. If you want the limit of this, you have to approach 2 from the left, from the right. So you have to come on this interval. So you have to use this expression. What these branches are doing when they approach 2. So we have to take the limit. So this expression we simplify as we did here. We see that these 2 lines are going to meet at 4. At 4 is nothing because it's undefined. But they are going to meet here when the y is 4. This point is in 1, so it's below. So this is the situation of the graph. Correct? So you cannot put a tangent right here. You cannot put a tangent right here because there is no point. Correct? So it's not differentiable, it's not continuous, but the limit exists, is here. Okay? Bueno, último problema. Last problem for today. Okay, another for horizontal asymptotes of the graph. Oops. Do you remember these functions, these exponentials? These are exponents. So if x is 100, 2 to the 100 is a big number. Much more than 5. Much more than 1. Okay? So what happened to this function when the x is very big? Now, who are the bigs in the class? 5, 1, 2 to the x. Who's the big one?
2 to the x and negative.
2 to the x, correct. So, horizontal asymptotes, this is the point of connection. Horizontal asymptotes is the limit at infinity, correct? So, what is the value of this function when the x is very big?
Infinity.
A ver.
Wait, no.
The top one, yes. The bottom one, yes. But together?
It's 0.
Is 0. A ver, Leo.
It's 1.
1. Areli.
-1.
Negative 1. Okay, let's see. Let me just put this one right here. So I have limit, bueno, y equals 5 plus 2 to the x over 1 minus 2 to the x. Okay, let me just switch screens right here. Okay, I have, for the horizontal asymptote, I have to take the limit at infinity, 5 plus 2 to the x over 1 minus 2 to the x. Now, suppose this is 100. This is 5, 2 to the 100, 2 to the 100. This is much more. So this is like we take 2 to the x over negative 2 to the x. What is this equals to? Negative 1, correct? So when the x is very big and positive, this is negative 1, correct? Okay. But the problem is, remember, the x is positive and the x is also negative. So I have to take this in this direction. Now I have to take this in this direction. Correct? Okay. Now I have to take the other limit. It's the same expression, but now I have to take the limit at negative infinity of 5 plus 2 of x, 1 minus 2 to the x. Now my numbers are going to be like this one, 2 to the negative 100. What is 2 to the negative 100 respect 5? Ahí está el cocodrile. ¿Para dónde se va a comer el cocodrile número? What number is greater? 5 or 2 to the negative 100?
5.
Correct. El cocodrilo come así. And the same one. 2 to the negative 100 is less than 1, correct? Right? So in this situation, when the x is negative, now the big guys are not 2 to the x or 2 to the x. Who are the big guys?
5 and 1.
5 and 1. So this is limit when the x approach negative infinity of 5 over 1. So this is 5. So how many asymptotes you have? 5 and negative 1, correct? Because the other one, déjame ponerlo aquí. Correct? So if you take the limit to the right, you get negative 1. If you take the limit to the left, you get 5. So the answer is you have two asymptotes, 5 and negative 1. The horizontal asymptote goes in both directions, acuérdense. The graphs are this one, x and y. So you go acá or for this direction, up and down. Questions here, muchachones? Easy on easy. Hicimos apenas 6 problems, okay?
Una hora.
We solved these 6 problems. Okay, okay. So, déjenme poner aquí la pantalla. Right? Esto. So, remember that these files are for you here. You can go, or you can go to the 525 and you can practice those that have detailed solution. Remember, I can explain you, but your success depends on how much you study. Yeah? If you study hard, you use the most time practicing, I'm pretty sure you're going to make it in the AP test. But if you just rely on these sessions, well, possibly you make something, but remember, the most you practice, the most you master. Okidoki.
Yes,
Bueno, voy a parar aquí